Let's begin. Today's October 17th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 5, 14, 18, 19, and 21. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. So criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will let us know if it's an even digit or an odd digit. Criteria card B will take a look at our 3 digits, triangle, square, and circle, and the Turing Machine will let us know which one is the absolute smallest. So should triangle be the smallest, should square be the smallest, or should circle be the smallest? Criteria card C again takes a look at our 3 digits, triangle, square, and circle, but this time it'll add the digits up, and the Turing Machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card D will take a look at our first 2 digits, add them up, and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E will take a look at our 3-digit solution, and it'll let us know a little bit about its structure, so to speak. One case is where the solution has a pair of digits, as in the example 131. Alternatively, the solution might not have a pair at all, but there are 2 scenarios. One where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card A. Okay, so the Turing Machine does approve of my choice for triangle. I did choose an odd 3, so the Turing Machine confirms that yes, triangle should be an odd digit. So let's go ahead and type that up in our notes in section A. And we'll say that triangle is an odd digit. And since it is odd, let's go ahead and cross out both evens. So let's go ahead and cross out 2 and 4. So the next thing I think I'd like to test is criteria card C. Okay, so criteria card C is having us add up all the 3 digits. So let's go and do that with my proposal. So 3 plus 1 is 4, and 4 plus 4 is 8. 8 is an even quantity, but since the Turing Machine does not agree with the sum of my proposal, it's actually letting me know that the sum total of the 3 digits should actually be odd. So let's go ahead and type that up in our notes for section C. And that is that triangle plus square plus circle should actually be odd. And so what sort of conclusions can we draw from that? Well, we've already established that triangle's odd. So that means that square and circle have to be of the same type. They either have to be both odd or both even. Because in those scenarios where they're the same type, whenever you add them together, that produces an even sum. And then when you add in the triangle odd value to any even, that sum total basically becomes odd. So we're looking at a potential solution that's all odd or odd, even, even. Okay. And so let's go ahead and test criteria card E to see maybe there's a pair or not. So let's go ahead and test E. Okay, so it does approve of my choice of 314. Notice that in this scenario, or for this criteria card, all the digits are distinct. So that means that the solution has no pairs. So let's go ahead and type that up in section E. And we'll say that the solution, again, has no pairs. Now, we could be looking at a scenario where, again, it could be that it's a single digit repeated 3 times. It's possible to have, the same 3 odds. However, now that I say that, if I take a look at criteria card B, B guarantees that there should be an absolute smallest. So that means that no, you can't have the same digit repeated 3 times because any one digit is not smaller than itself. So we can conclude here that they are going to be all distinct digits. So yeah, no pairs, but they are going to be all different. And so, but that really doesn't allow us to cross out anything because we really don't know what square and circle are. We don't know, maybe they're even. They could be all odd. Well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card B, identifying which is the absolute smallest, and we didn't test criteria card D, the sum of the first 2 digits being compared to the sum of 6. So if we're dealing with an all odd solution, it could be, and because they're different, it could be that the sum might be 6. So it could be 1, 5, or 5, 1. And then, of course, if we have 2 odds in triangle and square, that sort of forces circles to be odd as well. And so it could be that because they're also all distinct, we're dealing with 1, 3, 5 in some combination. But again, if it's the sum of 6, then obviously one of the triangle or square would have to be the smallest with 1. So it could be something like that. And we could have anything else, but I think that might be a good strategy to construct that second round proposal. So it could be something like 153 or 153 or 513. So let's go ahead. I'm gonna try out. Yeah, the sum of the first 2 will be 6. So let me pick 513. Yeah, that sounds plausible. So let's go ahead and try that out. So 513. And so again, the whole reason for this proposal is to verify that the sum of the first 2 is actually 6. So let's test criteria card D. Okay, yes, absolutely. So yeah, we do know that the sum of the first 2 digits, triangle and square, is actually 6. So let's go ahead and type that up, and we'll say that triangle plus square is equal to 6. And because we know that triangle is odd, then yes, absolutely, square has to be odd. And because an odd plus an odd is equal to an even. So let's go ahead and cross out all the evens in square and circle, we know those cannot be evens. And again, the only way you can get a sum of 6 with 1, 3, and 5 is, it has to be 1 and 5 for triangle and square in some order, and that would force your circle to be 3. So actually, I think we already know that circle should be 3. And now we'll simply test criteria card B to see which is the smallest. Again, because I'm saying that the sum is 1 and 5 to give us 6, either triangle or square has to be the smallest. So let's see if we got it right. And that's criteria card B. And yes, square is the smallest. Since in my proposal, out of the 3 digits, 1 is the smallest, Turing Machine confirms that. Yes, square is the smallest. And so that should be our solution. But in our notes, we'll just say here that square is the smallest. Let me write it out as it's the smallest digit. Let's see if I spelled that correctly. It looks like I am. Oh, got an extra I. Okay, and so yes, square must be 1. So let's go ahead and cross out the 3. And cross out the 5. And so that means that triangle must be the 5. And so let's cross out the 3 as well. And so, yeah, it looks like our solution is 513. Okay, and so let's go verify. Being a little temperamental. I think that may work. So 513. Fantastic. And how do we do versus a Turing machine? Well, I think there were 5. There we go. We had 5 criteria cards, and we tested exactly 5. It had 5 tests. So in the first round we did ACE, C being the only incorrect. In the second round we did the remaining 2 tests. So let's go ahead and type that up. And again, that was ACE. And so A was correct, C was incorrect, E was correct, and we got the solution in our second round. Okay, so we beat the Turing machine by 1 question. So, very fortunate the way it played out. Obviously, the first round really set us up with, just going into the second round where, I think we got perhaps lucky that we were able to get the sum of the first 2 to be equal to 6. And so, and it just kind of worked itself out after that. So, great puzzle. But how did you do? Did you pick a different set of a different set of criteria cards? And in what order did you play them? And did you discover anything interesting that you'd like to share? Add that to the comments. If you liked the video, please give it a thumbs up so that more people can find our channel. And of course, hit subscribe to not miss out on any future videos. Well, until next time, have a great one.